My name is Alex Sawatzka, and this is Lab 1 Charge Tapes for Spring 2023 Physics 2. The purpose of this lab was to observe interactions between different charged objects, specifically two pieces of charged tape. And then we were to determine the excess charge on a piece of charged tape. The formulas that we used in this experiment were the electric force, the magnitude of this force, and the electric field, using the constants, the Coulomb's constant and the number for the charge of an electron. In this experiment, we'll show that the tape is positively charged with a value of 6.34 times 10 to the negative 8 coulombs, and that it has an excess of 3.96 times 10 to the 11 electrons. The assumptions made while doing this experiment were that the system involved was the charged U-tape and whichever other object it was interacting with, for example, another U-tape, a pen, or another neutral object. We also assumed that air resistance or any other outside charges were to be ignored because they were too small to be significant. We also assumed that charge was evenly distributed between the two pieces of tape and treated both tapes as a point charge, and assuming that the U-tape was charged the same. Some potential errors would be the human error while measuring the distance between the tapes, and the different charges because of interactions with other objects. First, we had defined the force of gravity in this system, which was the mass of the tape multiplied by gravity, which we assumed the mass of the tape to be 0.2 meters times the 0.001 kilograms per meter, and then multiplied this by the gravity, which was 0.002 newtons. In this experiment, gravity and the electric force are equal, so the electric force was also 0.002 newtons, and we measured the distance to be 4.3 centimeters or 0.043 meters. And then we rearranged the equation for the electric force to find the value of the charge and got a value of 6.34 times 10 to the negative 8 coulombs, and then divided this value by the charge of an electron to calculate the amount of excess electrons in the system, and then used that value to calculate the atom ratio, which we received a value of 9.95 times 10 to the negative 7 electrons to one atom. Here is the GlowScript code associated with the data found in the previous slide. Here in this model, we see the 2 point charges of the charged tape in the green and blue balls, and then the yellow arrow representing the force of gravity in the system, and the purple arrow pointing up representing the electric force. As you can see here, the calculations of the tape charge, the electric force, and the excess electrons are included in this GlowScript code. Now we have what if the electrons had a positive charge and the protons had a negative charge. We would see that there would be very little change in this experiment. The objects in the experiment would switch charges. For example, the piece of tape would be negatively charged rather than positively charged. But it would not change any of the interactions between the objects, since the two like charges of the tapes would still repel each other, and the other interactions in the experiment would, the opposite charges would attract. It is important to handle these charge tapes as little as possible because we do not want to change their charge at all. Since the tape is positively charged, my hands are neutral, there's the chance of the electrons from my hands jumping to the tape and returning that tape to its equilibrium state and neutralizing it, changing the results of this experiment.